used to encrypt and decrypt messages. This algorithm is developed by three authors, that is Rivest, Shamir and Edelman. That's why the name of the algorithm is given as RSA. Rivest, Shamir, Edelman. So it is an asymmetric cryptographic algorithm. We know that in asymmetric algorithm we use private key and public key for encryption and decryption. So both sender and receiver use private key and public key for encryption and decryption. While in symmetric algorithm we have only one key for encryption and decryption. So till now we have seen symmetric algorithms. Here we are going to see one of the asymmetric algorithm, that is RSA algorithm. Now let us see the formula for encryption and decryption using RSA algorithm. This is the formula for encryption, that is C is equal to P raised to E mod N, where C is the ciphertext and P is the plaintext message. So for encrypting we need public key. Here public key is E. So C is equal to P raised to E mod N. And we have the decryption formula using RSA, that is P is equal to C raised to D mod N, where P is the plaintext message and C is the ciphertext message. So P is equal to C raised to D. D is the private key. So C raised to D mod N. Now here we need to calculate public key and private key, that is the value of E and the value of D and the value of N. Now let us see the key generation steps. These are the key generation steps. The first step is consider two large prime numbers P and Q. Here we need to consider the two prime numbers P and Q. And the next step is calculate N, which is equal to P into Q. Here we calculate the value of N, this N, as P into Q. These values, we have considered these values in step number 1. So the formula for calculating N is P into Q. And next step is phi of N is equal to P minus 1 into Q minus 1. Here phi of N is Euler's totient function, and which is calculated as P minus 1 into Q minus 1. And the next step is to select public key E such that it should satisfy the two condition, that is GCD of phi of N and E is equal to 1 and E should be greater than 1 and it should be less than phi of N. That is, we need to select one number E such that it should be coprime to phi of N. Now what is coprime here? Coprime is, we say that two integers are coprime if the only positive integer that divides both of them is 1. It is also called GCD of phi of N and E is equal to 1. So in this way we need to select public key E, which satisfies these two conditions. That is, E should be greater than 1 and less than phi of N, and GCD of phi of N and E is equal to 1. And the last step is find the value of D, which is nothing but the private key, and the formula for calculating the value of D, that is private key, is D into E mod phi of N is equal to 1. This is the formula for calculating the value of D. Now let us see the example for key generation steps. Here the step number 1 is consider two prime numbers. Here I have considered the two prime numbers P and Q, which is 3 and 5. So P is equal to 3 and Q is equal to 5. Here you can consider any two prime numbers. And the next step is calculate the value of n. So the formula for calculating the value of n is equal to P into Q. Here P into Q is 3 into 5, which is 15. So here we got the value of n 15. So the next step is calculate the value of phi of n. So the phi of n is equal to P minus 1 into Q minus 1. So here the value of P is 3 and the value of Q is 5. So the value of phi of n is calculated as 3 minus 1, 5 minus 1. So 2 into 4, which is 8. So the value of phi of n is 8. So in this way we have calculated the value of n and the value of phi of n by considering the two prime numbers. And the next step is to select the public key E. And the condition for selecting the value of E is the value of E, it should satisfy these two conditions, that is GCD of E and phi of n is equal to 1, and the value of E, it should be greater than 1 and it should be less than phi of n. Here we need to calculate the value of E which satisfies these two conditions. Now here I have considered these examples, like for example GCD of 3 and 8 is 1, where value 3, it satisfies these two conditions, that is 3 is greater than 1 and it is less than 8, and the GCD of 3 and 8 is 1. So here we can assume the value of E, that is 3, or else you can go with the other numbers, that GCD of 5, 8 is 1 or GCD of 7, 8 is 1. You can consider the value of E as 5 or 7. Here I have considered 3. So here value of E is 3, which satisfies these two conditions. So the next step is to find the value of D, which is private key. So we have the formula, that is D into E mod phi of n is equal to 1. So we have the value of E, which is 3, and we also have the value of phi of n, which is 8. So if we consider the value of D as 3, then 3 into 3 mod 8 is equal to 1, that is 3 into 3 9, 9 mod 8, which is equal to 1. So here we have calculated the value of D as 3. So here we now have the public key and private key En and Dn, that is public key E and N. We have calculated these values, that is 3 and 15, and the private key D and N, that is 3 and 15. Now we can go to the next step, that is encryption and decryption. So for encryption, here I am considering the plain text, which is 8. So we have the formula for encryption, that is C is equal to P raised to E mod n. So here we have calculated the value of E and N. So substitute these values in this formula, you will get the ciphertext. So C is equal to plain text 8 raised to value of E, that is public key, which is 3 mod n. So value of n is 15. So 8 raised to 3 mod 15. So the ciphertext is 2. So plain text is 8. After substituting the values in formula, we got the ciphertext 2. And the next is decryption. For decryption, we have this formula, that is P is equal to C raised to D mod n, where P is the plain text, C is the ciphertext. Now we have these values. Ciphertext is 2 raised to the value of D, which is private key. So the value of D is 3. So 2 raised to 3 mod n. Value of n is 15. So 2 raised to 3 mod 15, that is 8 mod 15 is nothing but 8. So plain text is 8. So here we have considered the plain text 8. We got the ciphertext 2. So after encrypting this plain text 8, we got the ciphertext 2, and in decryption we got our original plain text, that is 8. So this is how RSA algorithm works.